All right, we are going to be going over talking about linear inequalities with two variables. So on your line on the paper that you have, your first graph picture has the inequality on front. I know it's folded over. On the front, it has it going to the left. Okay. Left hand to the left. That is less than. Now, previously, when we talked about solving inequalities, we solved inequalities and we got an inequality that looked something like, say, x is less than 4. Okay. Now, to remind you, when it is less than, we are open. That means we are not including the value. So if we were to graph x is less than 4 on the number line, I would have the number 4 here. We know to the right of number 4 would be 5. To the left of number 4 would be 3. Okay. And our numbers would be getting smaller. Now, we're not including 4. 4 cannot be a solution because x is less than 4. So we would shade to the left of the number 4. Okay. Now, we're going to talk about dealing with a linear inequality with two variables. You must graph this. Now, they've already graphed it for you on the paper. Okay. So all we need to do, I'm sitting on it. Get off me. There we go. All right. Now we're in business. Okay, when we graph a linear inequality, typically we want it in slope-intercept form. Now, in order to talk about it being open, there's no line underneath. When we talk about being open and which direction our line is going, okay, we need to talk about whether or not we're smaller, okay? So look at your axis. We're going to look at our graph. So we're saying y, the y value is less than this rule, 1/2 x minus 3. Okay? Does that make sense? Okay, let's talk about our y values and our y-axis. As I'm going up, our y values are getting larger to positive infinity. As we're going down on the y-axis, we're getting smaller. Okay? So if we're talking about y is less than, that means the value of y is smaller than whatever we have on the right side. So we want to shade below. Now, an easy way, our line is going to be open, and in order to say open, we're going to say dotted. So I don't need to connect my line here on this. I can just put little slashes in between my slope points and call it a day. Okay. Now, we're shading below. I'm going to write my name like I would on a line. So my name is Epperson, so I'm going to write Eps. Okay. Or I like cats. So I'm going to put cats and write cats on the line. All right. So that my word is above the boundary line. We want to shade below. So I want to shade the side that does not have the word. Okay. So I'm going to shade this side. I am shading all the possible solutions. Now, let's talk about what are the possible solutions. Okay. Any point on the line is not a solution because it's open. Now, anything in the shaded region is a point and is a solution. So if I pick that point right there in that shaded region, that is the quadrant point for -3. For -3 is a solution, meaning if I were to plug it in for x and y, it would give me a true statement. Any questions? How do we feel about this? Okay, now the next one, our inequality is going to the right. We're still talking about it being open, and this is greater than. So that means that our y values in terms of our inequality are getting larger. So then we need to shade above. And our line is still going to be dotted. So we can just put little slashes in between our slope points that we graphed and graph it. And then we're going to shade above. So I'm just going to do one way to do this is just draw lines. You don't necessarily have to do a full color. Just draw a few lines in that area and you're good to go. Does that make sense? Again, I can put my name. So in this case, since we're shading above, we want to shade the side that has our name. To remind you, any point on the line is not a solution because it's open. This is open. Now, this is a really important possible solution, and we'll talk about it in just a moment, but the coordinate point 0, 0 is a possible solution. You can have any point on the line there on the x-axis. So let's say 2, 0 is a possible solution, but not 6, 0. 6, 0 is not a solution because it is on the boundary line. Let's go ahead and put the scissors up. Put the scissors up. You no longer need them. Put them away. So that you do not make poor decisions. See? Ándale. You forgot Pinkie Pies. Okay, now the next symbol we have is going to the left, but it has a line underneath, like an equal to. That is less than or equal to. To remind you, this is closed. Since we're less than, we're still like before going to shade below because less than still means the same. But because we're equal to, we're going to hit a solid line. So now when I draw my line, I'm going to go ahead and connect my dots. Possible solution is any point on the boundary line, as well as any point in the shaded. Since we said below, we want to shade on this side. We want to shade the side that does not have my name. And any point in the region. So I can have -4, 0, sorry, not negative 4, 0, 4, 0, negative 4. 6, 0, 8, 0, 5, negative 4. Those are all just possible solutions. Okay? Give me the toy. Okay, last one. We're going to the right. That means we're getting larger. Is going to be greater than or equal to. Just like when we were going to the right, we're shading above. But because we have a closed line, we're going to go ahead and connect our dots. We're shading above, so that means we want to shade the side of the boundary line that has our name. And we have a solid line. Again, any point on the line is a possible solution. 0, 0 is also a solution. So I want you to think about this. On this one, where it's greater than, in the terms of this graph, 0, 0 would be a solution. But if it was less than, it would not be. It would be a false statement. So it would not be a solution. Does that make sense? Okay. Now we're going to go to the other sheet.